This is lesson 3.9 notes. This is formula F on your formula sheet. It says the derivative of a to the u equals a to the u times natural log of a times the derivative of u with respect to x. One thing to remember, keep straight on this, is that a equals a constant. So a might be 8 or 7 or -3 or e or pi. It's going to be a constant. Okay? U equals a variable expression. Like 3x, or the square root of x, or tangent of x. Okay? It's going to have some type of variable expression in terms of x. So a is a constant, u is a variable expression. So for examples, let's say that you want to do the derivative of 9 to the 3x power. All I do is take 9 to the 3x, I just copy down my problem, a to the u, a to the u. So I go 9 to the 3x power times the natural log of a, so the natural log of 9, and then times the derivative of u. The derivative of 3x would just be 3, and that would be my answer. And this is one I'm not going to make you memorize. You'll have that formula to use on the test. Let's do one that looks a little bit different this time. Let's say y equals 4 to the sine of x power. So my a is 4, my u is sine of x. A equals 4, u equals sine of x. So what's my du over dx going to equal? Right here in the formula, what's that going to equal?
4 to the sine.
I'm just saying, what's the derivative of sine? Cosine. Okay, now we'll get to what you were going to tell me. You were going to tell me the answer. My derivative, dy over dx, or y prime. Formula says I copy down the problem, 4 to the sine of x power times the natural log of what? A, what's my a again? 4, natural log of 4 times du over dx, which I said was cosine of x. So don't make this too hard. When you do the derivative of a constant to a variable expression, you take the constant to the variable expression times the natural log of your constant, and then times the derivative of your exponent. That's the formula. Any questions about that one? Now I just want to point out the similarity of that one with this other formula. What if my constant is an e, which is about 2.7? Then it would look like this. E to the u times the natural log of e times the derivative of u. I just changed all the a's to e's. But what did we say the other day? What's the natural log of e equal to? Yeah, you got it. It was 1. Yeah. Because natural log of e, you're thinking, here's what you're thinking. You're thinking, okay, it's natural log means base e. E to what exponent equals e? E to the first power gives me e. So natural log of e is equal to 1. So natural log of e is equal to 1. So normally we don't even write that natural log of e down. Normally we just write this formula like this. Whoops. So they're really the same formula. It's just that we leave out the natural log of e because that's equal to 1. So this is formula on your sheet. This is one you need to memorize. You do need to memorize this second formula here. This is formula H on your formula sheet. So example C, I just did A and B. Let's say I was going to do the derivative of e to the x squared plus 3x. So all I would do is copy down the problem and then multiply by the derivative of the exponent. These are not hard. Copy it down. Here's the answer. E to the x squared plus 3x times, put this derivative in parentheses, the derivative of x squared plus 3x would be 2x plus 3. That's your answer. Okay? So don't make that too hard. Copy down the problem, multiply by the derivative of the exponent. So you have to memorize that. That's not, shouldn't be hard. Let's do another one. Let's say that f of x equals e to the secant of x. Now let's try to do f prime of x. I'm purposely using different symbols so you get used to seeing different symbols for derivatives. So I'm just going to copy it down. My formula says derivative e to the u is just e to the u times the derivative of u. So just copy down e to the secant of x. And then what would I multiply by?
Secant times tangent.
Right, derivative of secant is secant of x times tangent of x. That would be my derivative. Any questions about that?